Hello and welcome to CEO's Projects. Today we're going to go over how I went from V1 to V6 for my electric skateboard battery holder. Like all good projects, it all begins with a single sketch. This paper contains all of the sketches for each of the battery holders. This even includes the base models. So the only problem with all of this is that we were off by half a centimeter, and the half a centimeter was found on V1. V1 was a hole test to make sure that the holes matched up with the board, which I will show later. As you can see, it broke off a little bit, but as you can see written on here, battery holder V1 test. Cable holes, I need to move them 0.85 of a centimeter. And the back holes, I need to move forward half centimeter, either forward or backwards. Regardless, I had to move them. This was February 24th of 2023. So this was just a perfect test. And it also printed straight up and down, which is pretty awesome. So now we get to the second version, V2. V2 was the first model, as you can see with how grody and dirty it is and how duct tape it is, to see actual service. Now the problem with V2 was that it wasn't rounded, and when you have just sharp corners and thin, well, not necessarily thin, but just sharp corners and thin walls, and it hits the corner, it literally falls apart. As you can see here, the thing literally just came off. I remember I was standing on the board, accidentally sent it into a door, and I don't know if it was the wheels that hit it or just the impact of the door, the thing broke. And the door was literally just held on by duct tape, which that's an important thing for later. So after a huge amount of holding it back together with all of this different just melting 3D printer plastic and just putting it on there, you got some Mars up here, I decided that we needed a whole new version. This was also cut off of the door. Originally it was supposed to be about here-ish, which the problem with that was it just was extra filament and was blocking putting in the batteries, which ended up being just useless because I would have to take off the tape every single time and it would scratch up the batteries. So needing a new design, because this was effectively just not safe and not the greatest, we then ended up going to V3. V3 doesn't look like much. And you can't probably tell why. It's very, well, it's only half. If you look right here, which I'll see if I can zoom in, there's a massive layer shift in the print. So that massive layer shift was a problem because, as you can see, this isn't the print being finished. This is how thick I was printing them to make sure that they were strong. I mean, you can't really break it. So the problem is, if I printed this entire thing in one piece, what would happen would be, if there was any layer shift or any movement because it was in my college dorm, the entire print would be ruined because this offsets the holes by enough where it actually causes a problem. So then I thought, okay, how do we get around that? We print it in two parts. So V3, but in two parts, is V4. V4 was by far the most successful iteration at the time. It originally had, actually, you know what, I'll peel it off here. It originally had old bandsaw blades that I had cut up and fused into the middle to hold it in. It was going great and was functioning perfectly. As you can see, it was split down the middle and it was held together by crazy glue until I hit a bump and the thing just bottomed out. It split from under. And yeah, when you're traveling with lipos and you don't want them to explode, it's not really helpful. So, well, first, before I get to what I did to fix it, as you can see, the corners are rounded to help with deflecting angles, and the door is held on by screws, which means it's super easy and I don't need any more duct tape, which meant that this is a perfectly renewable and redoable process, which made my life a huge amount easier. This saw use from pretty much the entire school year once I had gotten the thing. So it was February to about May, June. So this served me a good 4 to 5 months. and eventually it did fall apart. I did try fusing it again. It didn't really work. Thankfully, the screws that were holding this into the board were acting also as structure, but this needed a fix because I couldn't ride around having the fear that if I hit a bump hard enough and the screws were out, it would just open up and I would be riding on a ball of fire. And so now we get to the still in use V5, the crowning achievement of this entire project. Now, V5 had a tiny problem. I originally was using the school-given SolidWorks, which was 2023. I have an OEM offline installer version of SolidWorks 2021 Premium. And if you've ever used SolidWorks before, you know that you can go forward, but you can't go backwards. So the files that I used for V1 through V4 were useless. I couldn't do it. So this is a derivative of those files in the way where I took the dimensions and I recreated it faithfully. Now, there are some differences, but overall, it's essentially the same. It's nearly a 1-to-1 ratio. So the holes are still the same for the screws. That's just filled with glue just because I didn't want to lose the bolts, which kept happening. Because, I mean, bumps are going to loosen the screws. So that is, yeah. I also cut it long ways in half because then it would be much harder and the batteries would put weight on both sides instead of just on the middle. So it'd be a lot harder to break. I also decided to go a little bit crazy. This white stuff that you see is not dirt. That's JB Weld. That is effectively crazy glue, but industrial size, or industrial type. So this was able to keep it from breaking. I mean, this thing is a brick. I stood on it and it didn't break, which was absolutely awesome. This thing has hit the ground so many times. It's been scratched up, it's been destroyed. This has essentially served me for, what, 2 full semesters, so almost an entire year. It's absolutely amazing. I made this in June-ish, I think, of last year because I needed something to replace V4, and this was done. I literally had the Prusa sitting right there, printing in a cardboard box, and it worked perfectly. Now, the other thing with this was originally, I attempted to do a fully toolless battery removal, and right here, as you can see, there is a little hole, or there's a, what do you call it, a circular cutout. That cutout is for, what do you call it? That cutout is for a magnet. It's supposed to be a neodymium magnet, or neodymium, however you say it. And that would also connect onto a door. This is not the original door, this is a secondary door that I made, which, once you would slide it in, the magnets would hold each other together, which it worked really well, until the same exact spot that killed V4 took the the door and bounced it up and down a little bit and flung it out, which thankfully I heard it happening because I heard the magnet fall off and I stopped immediately. So I ended up saying, you know what, oh well, and I went to using a screw on the door, but it's a single screw plus a lip. This just slides right in there. Sometimes you gotta lift it up a little bit and it goes perfectly in there. And it's absolutely perfect. I mean, I have had 0 problems with this at all. Because the thing is, it's encapsulated on both the top and the bottom. So it's really strong. I would honestly trust this with my life. That's how awesome this thing is. And so now, the batteries that we were using was a 9,000 milliamp hour LiPo 4S and a 5,000 milliamp hour 6S battery. The only problem with that is, as you can probably guess, when you use one battery that drains too fast, you almost kill it, which I did kill one. Thankfully, it killed it to the point where I just drained it a little bit too low, so it couldn't be recharged. So, not the end of the world, but still not the greatest. So, in fear of this, I wanted to see if I could make myself a better battery. A battery that would be perfect. Now, I didn't want to use V5, because V5 was for LiPos. V5 wasn't really, like, I had to remove the batteries to charge them. I did not want to do that with this new battery. This was going to use lithium ion cells, specifically 1850s I had pulled out of my scooter. And that leads to V6. V6, the final iteration up till now. of the skateboard battery holders. Now V6 has a bunch of holes, and it's literally V5 with no sliding door, holes on the side for the different mounting places, and that's really it. It's V5, but with less and more holes at the same time. So this did see some use, and then I ate it twice while riding, because the problem with the lithium-ion cells that I was using was that since the bike ESC, since the skateboard ESC uses, uses regen braking, it puts power back into the batteries, and the ESC didn't like that, so with the lithium-ion cells, and yeah, it would essentially just lock up and stop, or it would just break and do whatever. It wasn't good, and I ate it twice and fell twice. Thankfully, it wasn't this that caused it, but it was something else. So, yeah, so I ended up having to scrap that project, and I just stuck with lipos, which has led to a different skateboard being made, which you'll see in a later video. And yeah, but I mean, overall, V6 could literally be used as V5. Like, I could swap it out if I wanted to, and I didn't want to use the door, and I just wanted something to be more, just to be safer. It has JB Weld, but it also has hot glue, so it's a mixture. The JB Weld was the thing that holds it together. The hot glue was the thing that keeps it from going in the water. But, I mean, it's got holes that go all the way through, so I would have needed to use a heck of a lot more glue. The way how it would have worked was the BMS would have sat right here, and originally I discharged from the BMS, then I switched to discharging not from the BMS. Both just were terrible options. And we'd have one cell pack here, one cell back here. It was a 10S2P, so it gave me about a 5,000 milliamp hour battery, which was about the same, and it was pretty good. Like, I could have easily just plugged in the charger right here, and it was perfectly good. It just sucks that it didn't work, because, I mean, it would have been literally perfect. So, yeah, but I mean, that's V1, V6. This was literally, and I do mean literally, the first project that I ever did extensive designing and prototyping for. So I'm happy to share this with the world, and it just shows that 3D printing really is great for rapid prototyping, and sometimes even a final product, because once you get it right, you're pretty much good. Like, I could get this injection molded if I really wanted to. Will I? No, because the 3D printed one's perfectly fine. I could replace it instantly. So, I mean, if you end up designing something, just design it. You can use Tinkercad, you can use Onshape, you can use a whole bunch of these free softwares. But once you have your design, just only change small parts of it. Unless you really need to change a huge amount, like going from V4 or V2 to V4, you can change a lot, but just make sure you keep the stuff that works. Because if you change everything, then you're just creating a whole new design. Yeah, I only changed the parts that broke and weren't good and weren't, well, quality of life problems. So by doing that, I made something that's indestructible, easy to remove the batteries, easy to replace, and takes the least time for printing. So you can do whatever you want, just that's what I suggest. Make the changes short and sweet, unless it's something that really, really, really needs to be done. And cutting up your parts, always make sure that you do a cross section. Don't just do a flat line, because it's a lot easier to shear something on a flat line than if it's intertwined like that. So, yeah, I'm happy I got to share this with the world. So, thank you so much for watching. If you're still watching, I will see you next Sunday, and I hope you have a great day.